Welcome to Raw Perfect classes. In this video, I will discuss about computer network. In this video, I will discuss first module of data communication components. And these are the contents which I will discuss. First content is representation of data and its flow network. Second, various connection topology. Third one, protocols and standards. Then I will discuss OSI model. Then transmission media, LAN, wired LAN and wireless LANs. Then I will discuss about connecting LAN and virtual LAN. And after that, what are the techniques which are used for bandwidth utilization. In bandwidth utilizations technique, we will discuss about multiplexing, and in multiplexing we will discuss frequency division, time division, wave division and concepts on spread spectrum. Now I am going to discuss first point, that is related to representation of data and its flow. In this, we will say that when we want to transfer any data from one device to another device through a transmission medium, and this process is known as data communication. Today, computing and telecommunication both depend on this data transmission. It makes a variety of applications, and these applications include email, video chatting, internet and many more things. Now next topic, that is I will discuss component of data communication. When we want to communicate with any person, or you can say when one node want to send any message to another node, that is known as communication, that is known as data communication. But for data communication we have need some components. First component, we need message. If we have no message, then what we will send message, send information to any person. So message is first component of data communication. Message, what will message? Message is a piece of information that will use for transmission from one person to another person, and this message can be in the form of text file, audio file, video file, etc. Second component which will use for the data communication, that is sender. If there is no sender, then we cannot send the message. Sender is just like a simply device which sends the message. It can be computer, it can be mobile, telephone, laptop, video camera or any type of workstation which is used as a sender for sending the message. For if there is a sender, then must be there a receiver who will receive that message. So we can say that receiver is also a component of data communication. Receiver is just a device which receives the messages, and it can be in form of a computer, telephone, mobile, workstation, laptop, etc. Now next, transmission medium, or you can say communication channel. This is also a component of data communication. Communication channels are medium which connect two or more workstations, and workstation can be connected either by wired media or wireless media. Without transmission medium, you cannot be send or receive your information from one node to another node. Next is set of rules or protocol. This is very important component of data communication because when someone wants to send the data, it should be understandable to other person who receives that message. Otherwise, that message will be meaningless. For example, if A wants to send a message to B, but A writes the message in the form of Hindi, but B cannot understand Hindi, so it's a meaningless conversation. So there should be a set of rules for sending or receiving the message. Now I am going to discuss next what are the protocols and standards which are used for sending or receiving the message. Before going to start this topic, this you have to clear this diagram. In this diagram, I have shown that there is a one sender and a receiver. Sender sends a message to receiver and receiver receives that message, and the sender sends this message through the one transmission medium, and both messages follows the some protocols for sending or receiving the message. Now I am going to discuss what are the protocols and standards which are used to follow for the sending or receiving the message between one person to another person, that is known as protocols and standards. Now there are two types of mainly protocols which are used to sending or receiving data. First is TCP protocol, second is a IP protocol. TCP protocol means transmission control protocol. Transmission protocol which it's a responsibility to divide the messages into in the form of packets. TCP is responsible for dividing messages in packets on the source computer and resembling the received packet at the destination or recipient computer. It's a responsibility of TCP that first it divides the messages into packets on the source computer, then when it is received on the destination computer, then it assembled all the messages in correct sequence. It's a responsibility of TCP, and it also makes sure that packets have the information about the source of message data and destination of the message data, sequence in which message data should be assembled, and checks if the message has been sent or sent correctly to specific destination or not. This is the responsibility of TCP. Second type of protocol is IP. Do you ever wonder how computer determine which packet belongs to which device? What happens if message you sent to your friend and that message is received by your father? Scary, right? Well, if IP is responsible for handling address of destination computer so that each packet is sent to the its proper destination. So you can say that IP is responsible for sending message from source to destination, to right destination computer, because it has a IP address which is used for sending or receiving message. Now next topic I will discuss about what are the various connection topologies. What is topology? Topology is just like a structure of a network, how all the components are interconnected to each other. There are two types of topology. First type is physical, second type is logical topology. Now what are the types of network topologies? Here we discuss about physical topology. Physical topology is a geometric representation of all the nodes in a network. There are 6 types of network topologies which are used, like first bus topology, second ring topology, third one tree topology, fourth one star topology, fifth one mesh topology, and sixth is hybrid topology. Now first topology I will discuss about, that is the bus topology, and here you can see in this diagram there are number of 5 nodes, 5 computers which are connected with the one cable, but this one cable is cable that is connected to all the computers, that is known as network borne network cable. And here also one cable is also used for connecting this cable, and this is the form of bus topology. Now I'm going to discuss what are the characteristics of bus topology. First characteristics of bus topology is that it is designed in such a way that all the station, all the computers are connected through the single cable, that is known as backbone cable. And every node, each node is either connected to backbone cable by the drop cable and directly connected to the backbone cable. Means this is a drop cable. This is known as drop cable or directly connected by the cable. Now next, when a node wants to send a message over the network, when a node wants to send a message over a network, then it puts the message over the network. All stations, all computers which are available in the network will receive that message, whether it has been addressed or not. Next features, bus topology is mainly used in 802.3 Ethernet, 802.4 standard networks. Configuration of bus topology, which is very quite simpler as compared to other topologies, and the backbone cable, which is considered as a single lane and through which message is broadcast to all the station, all the computers. Now next, what method is used for the bus topology for accessing any informations? That method is known as CSMA, that is known as carrier sense multiple access. And carrier sense multiple access is also divided into two parts for solving any particular problems, that is known as CD and CA. CD means collision detection and CA means collision avoidance. So you can say that CSMA is a media access control, which is used to control the data flow from one node to another node, from source node to destination node, so that data integrity should be maintained. And data integrity means the packets which you send from one node to another node, they cannot be lost. And there are two types of two ways, two alternatives available for handling these problems, and these two methods, two ways are CSMA CD and CSMA CA. CSMA CD means CSMA, it means carrier sense multiple access collision detection, CD, and it is that method which is used to detect the collision. This method is only used for detection of the collision. When you once collision detected, then sender will stop transmitting the data, because it works on the recovery after collision. And CSMA CA is that type of access method which is used to only avoid the collision by checking whether the transmission media is busy or not. If the transmission media is busy, then sender waits for the waits for the media until it becomes the idle. And this technique effectively reduces the possibility of the collision and does not work on the recovery of after collision. So that's why it will check in advance collision. Now next, what are the advantages of bus topology? First advantage of bus topology is low cost cable, in which we use the bus cable that is very low cost. So its initiation or installation of cable is very low cost. And second is moderate data speeds, because we use in this coaxial or twisted pair cables which are used and which supports only up to 10 megabits per second speeds. And familiar technology, because this is familiar technology, so as the installation troubleshooting techniques are well known and hardware components also easily available. Next advantage is limited failure. A failure in the one node will not have any effect on the other node. Now, within within the advantages of bus topology, there is some disadvantages of bus topology. First is a extensive cabling. A bus topology is quite simpler, but still it requires a lot of cabling. This is the first disadvantage of bus topology. And second disadvantage is difficult troubleshooting, because it requires specialized test equipments to determine the cable faults. If any faults occur in the cable, then it will be disrupt the communication for all the nodes. So it's very difficult to troubleshoot the any error. Third, signal interference. If two nodes send the messages simultaneously, then signals of the both nodes collide with each other, and this creates the signal interference. This is the disadvantage of the bus topology. Reconfiguration difficult. Adding new devices to network, it would slow down the network. So this is also disadvantage of bus topology. Attenuations. Attenuation is a loss of signal which leads to communication issues, and repeaters which are used to regenerate signal, and this is the disadvantages of bus topology. Now, second topology I will discuss, that is known as ring topology. In this topology, all the nodes will be connected with each other in the form of ring. One PC connected to second, second connected to third, third connected to fourth, fourth connected to fifth, fifth connected to sixth, and sixth connected to first. And there is no end point. These are the features of this topology. First, it is just like a bus topology, but with the connected ends. Second, nodes that receive messages from previous computer, they will retransmit to next node. Third one, data flow in one direction, so it is known as unidirectional. Data flow in a single loop continuously, because there is no endless loop, and it has no terminated ends, means each node is connected to other node, but there have no termination point, there is no end point. And data in a ring topology which will flow in a clockwise direction, because it is goes in the one direction, that is known as a clockwise direction, and that is also known as a unidirectional form. The method which is used in ring topology for access any information, that is known as token passing. Token passing is a network access method in which token passed from one node to another node. And what is a token? Token is just a frame which circulates around the network. What is the working of token passing? Token passing's working is that a token first of all moves around the network. After that, it passed from computer to computer until it reaches the destination or target computer. Sender modifies the token according to their need and putting the address along with their data. Data is passed from one device to another device until target address or destination address is not matches. Once the token received by destination received device, then it sends the acknowledgement to the sender that it has received the message from sender that he has sent. And in ring topology, token is used as a carrier. What are the advantages of ring topology? First is network management. In ring topology, you can manage whole network. You can remove faulty devices from the network without bringing network down. Second advantage, product availability. Many hardwares, many software tools for network operations and monitoring are available. Third one is Cost. Twisted pair cabling is very inexpensive and easily available. Therefore, installation cost is very low. And fourth one is reliable. It's more reliable network because communication system is not dependent on the single host computer. So that's why it is very reliable topology. Disadvantages of this ring topology, same just like bus topology. It is difficult troubleshoot. It has a difficult troubleshooting. Failure level is more because breakdown in one station which leads to the failure of overall network. Third, reconfiguration is very difficult. If you want to add new devices, if you add any new device, that will be slow down the whole network. Delay. Communication delay is directly proportional to the number of nodes, and adding new devices, it increases the communication also delay. Now next topology is star topology. In star topology, there is a one central point, one central hub which is connected with all nodes. Example, PC1, PC2, PC3, PC4, PC5, PC6, all directly connected with this central hub, central computer. So this is like a star, and this is a star topology. In star topology, it is an arrangement of network in which every node is connected to central hub, switch or central computer, and it is point to point connection. Central computer, which is known as a server, and all other devices which are peripheral devices which are attached to this server are known as clients. Coaxial cable or RJ45 cable is used for connection for the computer. Hubs or switches, both are mainly used as a connection devices in a physical star topology. Star topology is most popular topology in network implementation. These are the advantages of star topology. First, efficient troubleshooting. Troubleshooting is quite efficient in star topology as compared to bus topology, ring topology. In bus topology, manager has to inspect the kilometers of cable. In star topology, all stations are connected to centralized network. So network administrator can go to the only with the single station for troubleshooting the problem. Network control, complex network control features which can easily implemented in star topologies, because any changes made in star topology are automatically accommodated. Limited failure, as each station is connected to central hub with its own cable. So failure in one cable will not affect the entire network. Familiar technology, star topology is also familiar technology as its tools are cost effective. Easily expandable, it is easily expandable because you can add new stations to open ports of the hub. Cost effective, star topology networks cost effective because it uses inexpensive coaxial cable. High data speeds, it supports bandwidth of approximate 100 megabits per second. Ethernet 100 base T is one of the most popular star topology network. And these are two disadvantages of star topology. First, if central point of failure, then all network will be goes down, because if central hub or switch goes down, then all connected nodes will not be able to communicate with each other. Cable, sometimes cable routing becomes very difficult when significant amount of routing is required. This is a tree topology. In tree topology, star topology, These are the star topologies. Star topology is connected with bus topology. When two topologies are connected with each other, that is known as tree topology. In tree topology, there is one root which is with which other nodes are connected, and this root is also known parent, and these are the child nodes. Tree topology combines characteristics of bus topology and star topology. Second, it is a type of structure in which all computers which are connected with each other in a hierarchical form. Topmost node in tree topology known as a root node, and all other nodes known as the descendants of the root node, and there is only one path exists between two nodes for data transmission. It forms a parent and child hierarchy. And these are the advantages of tree topology. First advantage, support for broadband transmission. Tree topology mainly used to provide broadband transmission. Signals are sent over long distances without being attenuated, without any delay. Easily expandable. We can add new devices to existing network. So we can say that tree topology is easily expandable. Easily manageable. In tree topology, whole network is divided into segments. Whole network is divided into segments. So start networks which can be easily managed and maintained. Error detection and error correction. Error detection and error correction both are very easy in the tree topology. Limited failure. Breakdown in one station does not affect the entire network. Point to point wiring. It has point to point wiring for individual segments. Disadvantages of tree topology: it is very difficult to troubleshoot any problem. It has a high cost because we use broadband transmission medium. Failure: tree topology mainly relies on main bus cable. If main bus cable will damage, then overall network will be goes down. Reconfiguration difficult. If new devices are added, then it becomes difficult to reconfigure. This is a mesh topology. In this topology, all nodes are connected with each other. First node is connected second, and this is the first node, second node, and third node and fourth node. First node will is connected with the fourth node, second node, and also connected to third. Like this, second, third, and fourth are also connected with each other. This is a type of mesh, and this is known as a mesh topology. Mesh technology is a arrangement of network in which computers interconnected with each other through various redundant connections, and there are multiple paths from one computer to another computer. It does not contain a switch hub or any central computer because and which acts as a central point of communication, and its example is internet. Internet is also a mesh topology, and mesh topology is mainly used for WAN implementation, wide area network implementation, where communication failures are critical concern. And mesh topology is mainly used for wireless networks, and formula for calculating how many numbers of cables which are used for the creating a mesh topology. We can use this formula for calculating the number of cables. For example, we have a 10 nodes, and we have to connect these 10 nodes in the form of mesh topology. Then we will how many cables we will need for the cabling these nodes. We can calculate like this: 10 multiply 10 minus 1 and divide by 2. 2 5s are 10, and 10 minus 1 is 9. 9 5s are 45. We have need 45 cables for connecting the all 10 nodes with each other in the form of mesh topology. And further mesh topology is divided in two parts: full mesh topology and partial mesh topology. In full mesh topology, all computers are connected with each other. But in partial mesh topology, some certain computers are connected to those computers with which they want to communicate frequently. And this is a partial mesh topology. What are the advantages of mesh topology? Mesh topology is reliable. It has fast communication. it has easier reconfigurations. Reliable means if any link breakdown will not affect the communication between connected computers. Fast communication means it's very fast between the nodes. Easier reconfiguration if any new nodes would not if any new node add in the network, then it would not be disturb the communication between other nodes. Disadvantages of mesh topology. This is the cost. Its cost is very high because in mesh topology large number of connected devices required, such as a router, more transmission media than other topologies. So it's very costly. Management mesh topology network, is very large form, and it has very difficult to maintain and manage. If network is not monitored carefully, then communication link will be goes down failure. Efficiency in this topology, redundant connections are high, so that's why it reduces the efficiency of the network. Now this is the hybrid topology. In hybrid topology, we combine the more than two topologies, that is known as a hybrid topology. Here we use star topology, ring topology, and bus topology, and combine these topologies with each other, and that is known as a hybrid topology. So here we can say that hybrid topology is a connection between different links and nodes for the transfer the data. When two or more different topologies are combined together, that is known as hybrid topology. If we say that similar type of topologies are connected with each other, they will not be say that is hybrid topology. For example, in one ICI bank we use ring topology, and another ICI bank we use the bus topology, and when we combine these two topologies, that is known as the hybrid topology. But if both banks we use ring topology, or both banks we use the bus topology or star topologies, then it will not be say that it is a hybrid topology. Now what are the advantages of hybrid topology? It is very reliable topology, because if faults occur in any part of network, then it will not be affect on the functioning of rest of the network. Scalable, size of the network, it can be easily expanded by the adding new devices without affecting the functionality of existing networks. It is very flexible. This topology is very flexible because it can be designed according to the requirements of organization. Effective, hybrid topology is very effective as it can be designed in such a way that strength of the network is very maximized and weakness of the network is minimized. Now next is the disadvantages of hybrid topology. It is a complex design. The major drawback of hybrid topology is design of the hybrid network. It's very difficult to design architecture of hybrid network. Costly hubs used in the hybrid topology is very expensive, as these hubs are different from usual hubs which are used in other topologies. So that's why it has a costly hub used. So that's why this is the disadvantages of hybrid topology. And costly infrastructure cost is very high as compared to other topologies, because in this topology lot of cabling, lot of devices also used for the creating the infrastructure. So that's why its infrastructure is very costly, and its design is very complex. It's use very high costly hub. So these are the three mainly disadvantages of hybrid topology. Now till we discuss about what is a representation of data. Representation of data and its flow network means when we want to send one message to another person, this is the flow of data. And what media we use for sending or receiving that message, that is known as the transmission media, communication media. And for these data communication, we use the some components, just message sender, receiver, transmission media, set of rules or protocols. And after that we will discuss about the what are the protocols and standards we use in the data communication. We discuss about protocols and standards, TCP or IP. In TCP we send the message, we send message in the form of packets. from source to destination place, and when that message reached the destination place, that message will be assembled by the TCP in a sequence way, so that message will be reached, and also give the acknowledgement back to the sender message is correctly received or not. And IP protocol is used for sending the message to right place by giving the address. And after that we discuss about topologies. There are six type of topologies we have discussed. First bus topology, second ring topology, third is star topology, then we discuss about mesh topology, then tree topology, then we discuss about mesh topology, then we discuss lastly for hybrid topology. And these after these topologies we will discuss about which type of OSI model is used in data communication in a data communication network. What is the OSI model? This is very important topic for your exam point of view. OSI model. OSI is stands for Open System Interconnection. OSI means Open System Interconnection. In OSI there are 7 layers. Why we say this open? Because open stands to say non-proprietary, not paid. It is a 7-layer architecture with each layer having specific functionality to perform. All these 7 layers work collaboratively to transmit the data from one person to another across the globe. OSI reference model was developed by ISO. ISO means International Organization for Standardization in the year 1984. First, we discussed that OSI stands for Open System Interconnection. Why it is open? Open means it has it is non-proprietary. So it has 7-layer architecture and each layer has a specific functionality to perform. And each and every layer they are used for the transmission of data from one person to another person across the globe. OSI reference model was developed by ISO in 1984. ISO means International Organization for Standardization. Now OSI model provides a theoretical foundation for understanding network communication. However, it is usually not directly implemented in its entirely in the real world networking hardware or software. Instead, specific protocols and technologies which are designed based on the principles which are outlined in the OSI model for facilitate the efficient data transmission and networking operations. Now you have to clear what is the OSI model. First, I told you OSI stands Open System Interconnection. Second, I told you open stands means to say non-proprietary. Third, it has 7-layer architecture with which 7-layer architecture each and every layer has a specific functionality to perform, and all these 7 layers work collaboratively to transmit the data from one person to another person across the globe. OSI reference model developed by ISO. ISO means International Organization for Standardization in the 1984. OSI model provides a theoretical foundation for understanding what is the network communication. And it is also usually not directly implemented on entirely in the real world networking hardware or software. Instead, specific protocols or technologies which are oftenly used for designing the principles which are outlined in the OSI model for facilitating efficient data transmission and networking operations. Now I am going to discuss about what are the 7 layers of OSI model. This is the first layer. This one is the first layer, physical layer, second data link layer, third network layer, fourth transport layer, then fifth session layer, presentation layer, then application layer. And physical layer, which is responsible for moving individual bits. When we send data, that data will be in the form of bits from one device to next device. Data link layer's work is, it will take the bits from physical layer and send to the network layer. So data link layer is responsible from moving frame from one hop to next hop, and this frame is a combination collection of individual bits. And when data link layer send the frames to network layer, then network layer's responsibility is that to deliver the individual packets from source to destination. And after that, when the network layer sent these packets to transport layer, now transport layer's responsibility to send the data means to process to process delivery. It's responsibility of transport layer for process to process delivery. After that, transport layer send the process to session layer, and now session layer's responsibility to establish, maintain, synchronize and terminate the interaction between sender and receiver. When session layer maintains each and everything, then after that presentation layers takes care of syntax, semantics of the information, exchange the information between two communication system. And after presentation layer, now application layer's responsibility for providing services to the user. These are the 7 layers. First of all, physical layer takes the inputs in the form of bits from one device to next device. It will send that information because it's the responsibility for moving the individual bits from one device to next device. And then second layer, data link layer, its responsibility taking the bits in the form of frames from and takes the bits from frames from one hop and send these frames to next hop. It's responsibility of data link layer. And data link layer works between the network and physical layers. And now network layer's responsibility is to take the frames from a data link layer and convert them into packets and send from source to destination place. And network layers then connect with the transport layer. Now transport layer's responsibility to make the processing from one source to destination, means process to process delivery is responsibility of transport layer. After when the transport layers completes their responsibility, then responsibility of session layer to establish, maintain, synchronize and terminate all the interaction between the sender and receiver. And after that, presentations layer maintains take care of the syntax, semantics of the information exchange between two communication system. And after that, application layers responsibility for providing services to the users. Now I am going to discuss each and every layer in detail. First layer is physical layer, that is known as layer 1. The lowest layer of OSI reference model is physical layer. It's responsible for the actual physical connection between devices, and physical layer contains information in the form of bits, and it is responsible for transmitting individual bits from one node to a next node when receiving the data. And this layer will get the signal received and then convert into 0 and 1 forms, that is known as a bits form and bytes form, and send them to the data link layer, and which will put the frame back together. What are the functions of a physical layer? First bit synchronization, second bit rate control, then physical topology, then transmission mode. Bit synchronization The physical layer provides the synchronization of bits by providing a clock, and this clock controls the both sender and receiver, thus providing synchronization at the bit level. And second one is bit rate control. Physical layer also defines what is the transmission rate, number of bits sent per second, how many bits sent on the sent per second. And physical topologies, physical layers specify how the different devices nodes are arranged in a network in the form of a bus, star or mesh topology. It's clear from the physical topology. And transmission mode, physical layer also defines how the data flows between the two connected devices. Various net transmission modes possible, as they use the simplex, half duplex or full duplex method. And these are the bits form 1100, 111, these are the individual bits form. And here we used hub, repeater, modem, cables. These are the physical layer devices which are used in physical layer. In a network layer, data link layer, physical layer, also known as lower layer or hardware layers. Now, next layer is a data link layer, that is the second layer. Data link layer is responsible for the node to node delivery of the message. Node to node delivery of message. The main function of this layer is to make sure that data transfer is error free from one node to another node and over the physical layer. When a packet arrives in a network, it is responsibility of a data link layer to transmit that information to the host using MAC address. And the data link layer is divided into two sub layers: logical link layer control or media access control. The packet received from network layer, that packet which is received from network layer is further divided into frames, and depending on the frame size of NIC, network interface card. And data link layer also encapsulate sender and receiver's MAC address in the header. Encapsulate means to hide. And receiver's MAC address is also obtained by the placing an ARP address resolutions protocols, and which is request on the onto wire asking who has the IP address, who has that IP address, and the destination host will reply with its MAC address. Now, what are the functions of data link layer? First function is framing. Framing is a function of data link layer because it provides a way for sender to transmit, to send a set of bits which are meaningful to receiver. And this can be accomplished by attaching special bit pattern to the beginning and end of the frame. Physical addressing. Physical addressing means after creating frames, when they create a frame, then data link layer adds physical address, that is known as MAC address of the sender and receiver in the header of each frame. And after that, error control. Data link layer provides mechanism of error control in which they can detect and retransmits the damage for the lost frames. And next, flow control. The data rate must be constant on the both sides, else the data may be get corrupted. And flow control coordinates. The flow control coordinates the amount of data which can be sent before receiving an acknowledgement. Next is access control. When a single communication channel is shared by multiple devices, MAC sub-layer of data link layer also helps to determine which device has control over the channel at a given time. Now next, this is physical layer, and this is a data link layer, and this is a network layer. Take physical layer, number of bits sent in the form of frame. Data link layer sends the frames to physical layer, and network layer sends packets to data link layer. Divides the packets into frame, adds the header, destination, source address, and error control bits, etc. This is the responsibility of data link layer. Note: packet in the data link layer is referred as a frame. Data link layer is handled by NIC, network interface card. and device drivers of the host machine. And switch and bridges are also known are data link layer devices. Now, third layer is a network layer. The network layer works for the transmission of data from one host to other host located in the different networks. It also takes care of packet routing because selection of the shortest path for transmitting the packet from number of routes available. Sender receiver's IP address are placed in the header by the network layer. What are the functions of network layer? Now function of a network layer, first function is routing. The network layer protocol determine which route is suitable from source to destination, and this function of network layer is known as routing. Logical addressing to identify each device inter-network uniquely. The network layer defines an addressing scheme, and senders, receivers, IP addresses, they all are placed in the header. Sender and receiver's IP address also placed in the header by network layer. Such address differentiates each device uniquely and universally. We should be keep in mind that segments in the network layer is referred as a packet, and network layer is implemented by networking devices and such as routers or switches. Now next layer is transport layer. Transport layer provides services to the application layer. Transport layer provides services to the application layer and takes the services from network layer. Data in transport layer is referred to segments. Data which is used for the sending in transport layer, that is known as segments because it is responsible for end-to-end delivery of the complete message. Transport layer also provides a acknowledgement of successful data transmission and retransmit the data if error is found. At the sender's side, who sends the message, that is known as a sender. And at the sender's side, transport layer receives the formatted data from upper layer and performs segmentation and implement flow and error control method for ensuring that proper data transmission. And it also add source and destination port numbers in the headers and forward that segmented data to the network layer. We should keep in mind that sender needs to know port number and which is associated with the receiver's application. Generally, this destination port number is configured either by the default or manually. For example, when a web application requests a web server, it typically uses a port number 80 because this is the default port assigned to the web application. Many applications have default ports assigned, and at the receiver side, transport layer reads that port number from its header and forwards the message which has received to the respective application, and it also performs sequencing and reassembling of the segmented data. Now, what are the functioning of the transport layer? These are the functioning. First, segmentation and reassembling. Transport layer accepts the message. First, transport layer, what will do transport layer? First, it accepts the message from a session layer, then breaks that message into smaller unit, and each of these segments which produce a header which associated with it, and transport layer at the destination station resemble that message. Service point addressing to deliver the message to correct process. Transport layer header includes a type of address that is known as service point address or port address. Thus, by specifying this address, when we specify this address, the transport layer makes sure that message is delivered to correct process and services provided by transport layer. And there are two type of services provided: connection oriented service and connection less services. Connection oriented service, it has three phase process, which includes connection establishment. First of all, it create the connection, then send the data, and after that terminate that connection. These three processes perform in the connection oriented services. In this type of transmission, receiving data sends an acknowledgement back to the source after a packet or group of packet is received. This type of transmission is reliable and secure. Second type is a connection-less service. It is a one-phase process which include data transfer, and in this type of transmission, receiver does not acknowledge recipients of a packet. And this approach, which allows for the much faster communication between the devices. Connection oriented service is more reliable because it is created connection, it sends the acknowledgement, and connection less services does not send any acknowledgement for a receiving of the packet. Some points should be keep in mind. Data in transport layer is called segment. Transport layer is operated by the operating system, and it is the part of operating system. Communicates with the application layer by making system calls, and transport layer is called the heart of the OSI model. And device or protocols used in this layer, that is TCP, UDP, NetBIOS, and PPTP. Now, this is the session layer, layer number 5. This layer is responsible for establishment of connection, maintenance of sessions, authentications, and also ensure security. What are the functions of session layer? First function of session layer is session establishment, to establish the session, then to maintain that session, and after that terminate. Layer allows two processes to establish, use, terminate a connection. Synchronization, this layer also allows a process to add checkpoints that are considered synchronization points in the data. And these synchronization points also helps to identify error so that data is resynchronized properly and ends of the message not cut prematurely, and no data lost is avoided. Dialogue control, the session layer allows two systems to start communication with each other in half duplex or full duplex. There are some points you should be keep in mind that first, all the below three layers, including session layers, they are integrated as a single layer in TCP IP model as a application layer. Implementation of these three layers is done by network application itself, and these are also known as upper layer of the software layer. And device or protocol which are used in this layer, that is NetBIOS and PPTP. Now, example of this layer. Let us consider a scenario where a user wants to send a message through some messenger application which is running in their browser. Messenger here acts as a application layer which provides the user with the interface to create the data. And this message, so-called data, is compressed, optionally encrypted if the data is sensitive, converted into bits form 0 or 1, and so that it can be transmitted. Here data sends the message to receiver, and that message is converted into the encrypted form, and then after the reaching the receiver's destination, that will be decrypted by the receiver. Then that message will be get by the receiver. This is the communication between session layer. Now, this is the presentation layer. This is the sixth layer. Presentation layer is also known as translation layer. The data from application layer is extracted from here and manipulated as per the required format to transmit over the network. Functions of a presentation layer: it translate the information SCI to BCDI code. Encryption or decryption is also performed here in presentation layer. Data encryption translates the data into another form or code. The encrypted data is known as cipher text, and decrypted data is known as a plain text. A key value is used for encrypting as well decrypting that data, and compression reduces the number of bits which are need to be transmitted on the network. Device or protocol used for this JPG, MPEG and GIF form. And this is the last layer of OSI model, that is the application layer. At the very top of the OSI reference model, OSI reference models stack of the layer, we find that application layer which is implemented by the network applications. These applications produce data to be transferred over the network, and this layer also serves as a window for the application services to access the network, and also to displaying these for displaying received information to the user. Example applications, browsers, Skype, Messenger, etc. We should keep in mind that application layer is also called desktop layer, and device or protocol used for SMTP. What are the functions of application layer? The main function of application layer are given below. First, network virtual terminal. It allow user to log on to remote host. File transfer, access and management. This application allows the users to access the files in a remote host and retrieve the files in a remote host, and manage and control files of remote computer. Mail services, it provides a email service. Directory services means this application provides distributed databases or sources and access to global information about the various objects and services. Note: the OSI model acts as a reference model because it not implemented on the internet because it's of its late inventions. So current model being as used is the TCP/IP model. Till we have discussed about OSI model. There are 7 layers. First, physical layer. Second, data link layer, and third one is network layer. Fourth is transport layer. Fifth, session layer. Sixth, presentation layer, and seventh is application layer. In physical layer, physical layer's responsibility for moving data in the form of individual bits from one device to next device, and data link layer is responsible for the moving frame one hop to next hop. Network layer is responsible for delivering individual packets from source to destination. Transport layer is responsible for process to process delivery, and session layer is establish, maintain, synchronize, terminate the interaction between sender and receiver, and presentation layer takes care of syntax and semantics of the information exchange between two communication system, and application layer responsible for the providing services to the user. And all these layers should be placed as it we have discussed in this video. Now next topic is, that is transmission media. What is a transmission media? Transmission media means that medium by which we communicate from one person to another person, like your telephone, your mobile, your laptop, your radio, anything which is used for the communication purpose, that is known as the transmission media. So you can say here that transmission media is a communication channel which carries the information from sender to receiver, and data is transmitted through the electromagnetic signal. The main functionality of transmission media is to carry the information in the form of bits through the LAN, and it is a physical path between transmitter, receiver and data communication. And in copper based network, bits in the form of electrical signals. In fiber based network, bits in the form of light pulses. In OSI, open system interconnection phase, transmission media supports layer 1. Therefore it is considered to be as a layer 1 component. Electrical signals can be sent through the copper wire, fiber optic, atmosphere, water, vacuum, etc. The main characteristics and quality of data transmissions are determined by the characteristics of medium and signal. And transmission media is two types. Either it is wired media or wireless media. In wired media we use the wire, and in wireless media we use the signals. And different transmission media have different properties: bandwidth, delay, cost, and ease of installation and maintenance. Transmission media is also available in the lowest layer of the OSI reference model, that is known as physical layer. Some factors which are need to consider for designing the transmission media. First is bandwidth. All factors are remaining constant. The greater bandwidth of the medium means higher the data transmission rate of signal. Second, transmission impairment. When the received signal is not identical to the transmitted one, due to the transmission impairment, means quality of signals is not good, that will get destroyed due to transmission impairment. Interference. Any interference is defined as the process of disrupting a signal when it travels over a communication medium on addition of some unwanted signal, that is known as interference. Some factors which are considered for designing transmission medium. Now I am going to discuss about what are the transmission media. There are two types of transmission: guided media and unguided media. First, in we will discuss about guided media. In guided media, we discuss about coaxial, fiber optic, and twisted cables. Coaxial cables are further divided into baseband and broadband. Baseband and broadband, and twisted pair also divided into parts: unshielded or shielded twisted pair cables. Unguided media further divided into radio waves, microwave, or infrared. Now, guided transmission media in computer network. Guided transmission media is also referred as bounded or wired media, which are essential, and these medias are actual channels that direct the signals between the connected devices into networks. There are there are the types, some types of the guided transmission media. First is twisted pair cable. We will discuss about twisted pair cable. Twisted pair cable is a physical media which is made up of pair of cables twisted with each other, and a twisted pair cable is cheap as compared to other transmission media. So installation of twisted pair cable is very easy. It's a high lightweight cable, and frequency range for twisted pair cable is 0 to 3.5 kilohertz, and twisted pair cables have become common in LAN, phone lines, etc. They also available in two types: unprotected twisted pair cable and shielded twisted pair. Twisted pair consists of two insulated copper wires which is arranged in a regular spiral pattern. You can see this is the twisted pair cable. You can see that there are two cables which are twisted with each other, pink and blue color, and this one is a bare wire, and this part is the jackets of that twisted pair cable. And twisted pair cable further divided in two parts: unshielded twisted pair or shielded twisted pair cable. Unshielded twisted pair cable is widely used in telecommunication purpose, and following categories of unshielded twisted pair cable. First is a category 1, 2, 3, 4, and 5. In category 1, used for telephone lines which have low speed data, and category 2 is used and it can support up to the 4 megabits per second. Category 3 supports up to 16 megabits per second, and category 4 can support up to 20 megabits per second. Therefore it can be used for long distance communication purpose, and category 5 it can support up to 200 megabits per second. What are the advantages of USTP, unshielded twisted pair cable? It is a very cheap. Installation of UTP is very easy, and it can be used for high speed LAN. Disadvantage of this cable is used for the shorter distance because of attenuation. Shielded twisted pair (STP) is a cable which contains the mesh surrounding the wire, so that's why allow the higher transmission rate. Characteristics of STP: the cost of STP cable is not very high, not very low. Installation of STP is easy, and it has higher capacity as compared to UTP, and it has a higher attenuation, and it provides the higher data transmission rate. But disadvantages of this, that it is more expensive as compared to UTP and coaxial cable, and it has a higher attenuation rate. Now, coaxial cable is very commonly used transmission media. We use in TV wires, TV wire is usually coaxial cable, and the name of cable is coaxial because it contains two conductors parallel to each other, and it has a higher frequency as compared to TP cable, twisted pair cable. Inner conductor of coaxial cable is made of copper, and outer conductor is made of copper mesh, and middle core is made up of non-conductive cover and which separates the inner conductor from outer conductor. Middle core is responsible for data transferring, and copper mesh which prevents from EMI, electromagnetic interference. This is the coaxial cable. This is the jacket, this is the shield, and this is the insulator, and this part is the central conductor. Coaxial cable is of two types, baseband and transmission. Baseband defined that as the process of transmitting single signal at a high speed. Broadband transmission is the process of transmitting multiple signals simultaneously. Advantages of coaxial cable: data can be transmitted at a high speed. It has better shielding as compared to twisted pair cable. It provides a higher bandwidth. Disadvantages of coaxial cable: it is more expensive as compared to twisted pair cable. If any fault occurs in cable, it causes failure in the entire network. So that's why this is the disadvantages of coaxial cable. Now fiber optic. Fiber optic cable is a cable which uses electrical signals for communication. Fiber optic is a cable that holds the optical fibers coated in plastic that are used to send the data by pulses of light. And plastic coating protects the optical fiber from the heat, cold, electromagnetic interference from other type of wiring. Fiber optic provides faster data transmission as compared to copper wires. Basic elements of fiber optic cable. These are the basic elements. First is a core, cladding or jacket. Core, the optical fiber consists of narrow strand of the glass plastic. This is known as a core. A core is a light transmission area of fiber. More the area of core, more light will be transmitted into fiber. Cladding, the concentric layer of glass is known as a cladding, and the main functionality of cladding is to provide a lower refractive index at the core interface as to cause reflection within the core so that light waves which are transmitted through the fiber. Jacket is used for the protection of coating consisting of plastic, that is known as a for the protection of the coating, and that is known as a jacket. The main purpose of jacket is to preserve the fiber strength, absorb shock, and extra fiber protection. These are the following advantages of fiber optic cables. First is greater bandwidth. It provides more bandwidth as compared to copper, and fiber optic carries more data as compared to copper cable. Fiber optic cables carries data in the form of light, so it allows the fiber optic cable to carry signals at a higher speed. Fiber optic cable carries the data at a longer distance as compared to copper cable. Better reliability, it provides a more reliability as compared to copper cable, and because it is immune to the any temperature which changes, while it can cause obstruct in the connectivity of copper cable. Thinner and sturdier. Can the fiber optic cable is thinner and lighter in weight, so it can be withstand more pull pressure than the copper cable. Now this is a application of guided transmission media. First we will use wired transmission media, guided transmission media in local area network, wide area network, internet backbone network, telecommunication networks. In a local area networks, guided transmission media, particularly coaxial cable, twisted pair cables, are often used to link the computers and other devices with a specific geographic area. And wide area network, due to their high bandwidth ability to transfer data over longer distance without significant loss, optical fiber cables are used for the wide area networks. Internet backbone networks, a lot of data can be easily and quickly sent across the continents due to the internet core, and which is made up of high capacity fiber connections. And telecommunication network, a lot of data which can be easily and quickly sent across the continents due to the internet core, which is made up of high capacity of fiber connections. Now these are the advantages of guided media, guided transmission media. First, reliability. There is a high reliability of stability which is provided by guided transmission medium. Second, security. It also provides more security as compared to other medium, and it is more difficult to have for the hackers to intercept signals, which improves the network security in general. It provides a higher bandwidth because it enables the transmission of greater amount of data faster speed, less susceptible to interference because this feature ensures the signal integrity and makes them useful for higher electrical noise settings. Predictable performance, it provides a predictable performance, and you can say that management of signal behavior, accurate control, they are perfect to the for the application where stability is more important. Suitable for the long distances. Optical fibers have a low signal reduction, so it makes the perfect for long distance communication. So cost effective for the short distances. They also preferred choices for some connections between devices local area networks. But there are some disadvantages of guided transmission media. Limited mobility, because of this restriction, mobility and flexibility. This is a limited mobility. This is the advantage of guided transmission media because they have need the more cables for the connecting the network devices. Vulnerability to physical damage. Even cables guided transmission media are at the risk of physical harm, and communication can be interrupted by the construction of environment, accidental cuts, and these situations require maintenance repair. Cost for long distances. Since optical fibers other guided media are great for the long distance communication, initial installation cost of these systems can be high. For companies small budgets, this cost is maybe problem. So that's why this is the difficulty of guided transmission media. Limited bandwidth for some times. As compared to wireless technology, few guided transmission media types such as twisted pair cables may have the lower bandwidth sizes for application require high data transfer rates. So that's why it is a issue of a guided transmission media. Infrastructure dependency. This media mostly depending upon the physical infrastructure. So that's why this is also disadvantage of guided transmission media. Environment environmental impact. There can be environmental effect on the production disposal of guided transmission media, particularly cables. The creation of the more environmentally friendly sustainable alternatives becoming more and more important as a technology develops. Now I am going to discuss unguided transmission media. An unguided transmission transmits the electromagnetic waves without using any physical medium. Therefore, it is also known as wireless transmission. In guided media, air is the media through which electromagnetic energy can flow easily. Unguided transmission media further divided three parts: radio waves. Radio waves is magnetic waves which are used for the transmission in all direction of free space. And radio waves are omnidirectional. Signals are propagated in all directions. Range in the frequencies of radio waves from 3 kHz to 1 kHz. In the case of radio waves, sending receiving antenna are not aligned. Waves sent by the sending antenna can be received by receiving antenna. Example, radio wave FM radio. This is the this picture is used for the used radio waves, and here you can see that this is the ground wave and this is the sphere, and you can see there is a Wi-Fi connections they created for the communication purpose. Application of radio waves. These creates the waves for communication purpose. Application wave is useful multicasting when there is one sender and many receivers. In FMA, radio, television, cordless phones are example of radio waves. Advantages of radio transmission. It is mainly used for wide area network, mobile cellular phones, and it covers large area. They can penetrate the walls, and it provides a higher transmission rate. Microwaves further divide two parts: terrestrial microwave transmission and satellite microwave transmission. Characteristics of microwave frequency range. Its frequency range of terrestrial microwave is 4 to 6 gigahertz to 21 to 23 gigahertz. Bandwidth is sports bandwidth 1 to 10 megabits per second. Short distance is inexpensive for short distance. Long distance is expensive because require higher tower for the longer distance, and attenuation means loss of signals. It is affected by environmental condition and antenna size. Advantages of the microwave. Microwave transmission is cheaper than using cables. It's free from land acquisitions, and provides easy communications, and communication over oceans can be achieved by using microwave transmission. But disadvantages of microwave transmission: eavesdropping means it creates the in-sphere communication, and any malicious user can be catch the signal in the air by using their own antenna. Out of phase signal, a signal can be moved out of phase by using microwave transmission susceptible to weather condition. A microwave transmission susceptible to weather condition because it means any environmental change such as rain, which can distort the signal. And bandwidth limit means allocation of bandwidth which is very limited in the case of microwave transmission. Satellite so that's why we use a satellite microwave communication. A satellite is a physical object which revolves around the earth, that is known the height. Satellite communication more reliable because it offers more flexibility than the cable and fiber optic system. And in this we can communicate any point of the globe by using satellite communication. And how does the satellite work? Satellite accept signals and then transmit from earth station, and it amplifies the signals, amplified signal transmitted to another earth station. Advantages of satellite microwave communication. Coverage area of satellite microwave is more than terrestrial microwave, and transmission cost of the satellite which is independent of the distance from center of the coverage area. And satellite communication which is used in the mobile and wireless communication application is very easy to install, easy used in the wide variety of application: weather forecasting, radio, TV signal broadcasting, mobile communication, etc. Disadvantages of this satellite microwave communication. Satellite design and development fee requirements more time and higher cost, and it needs to be monitored and controlled on the regular basis. And life of satellite is about 12 to 15 years. Due to this reason, another launch of the satellite has to be planned before it becomes non-functional. Now last communication media is infrared in unguided medium. First, infrared transmission is wireless technology which is used for communication over short ranges, and frequency of infrared in the range 300 gigahertz to 400 terahertz, and it's used for the short range communication and data transfer from between two cell phones, TV remote operations, data transfer between computer, cell phone which are resides in the same closed area. Characteristics of infrared: it supports high bandwidth, data rate will be high, cannot penetrate the walls. Infrared communication one room cannot be interrupted by nearby rooms, and it provides better security with minimum interference. And it is unreliable outside the building because the sun rays will interfere with the infrared waves. uh, till we discuss about guided or unguided medium. It means wired media or non-wired medium. Now I am going to discuss about what is a multiplexing. In this video, I have discussed full one module in one media. One module in one video, so that you can prepare your exam properly. Um Multiplexing is a technique which is used to combine and send the multiple data streams over a single medium. The process of combining data streams is known as multiplexing, and hardware used for multiplexing is known as multiplexer. Multiplexing is achieved by using a device. What is a multiplexing? Multiplexing is a technique which is used to combine and send multiple data over a single medium. Main process of combining the data streams, that is known as multiplexing, and hardware which is used for multiplexing, that is known as multiplexer. Process known as multiplexing and hardware is known as multiplexer. Now multiplexing is achieved by using a device that is known as multiplexer mugs, and that combines n input lines to generate single output. Means multiple input lines and generate one output. Means many to 1. Here we use many to 1. Demultiplexing is achieved by using device that is demultiplexer, demux, available at the receiving end, and this separates a signal into its component signal. One input, one to many method is used in demultiplexing. We can say that one input and many output follow one to many approach. Transmission medium is used to send the signal from sender to receiver. Medium can only have one signal at a time. If there are multiple signals to share one medium, then medium must divided in such a way that each signal is given some portion of available bandwidth. For example, if there are 10 signals, bandwidth of medium 100 units, and 10 unit is shared by each signals. When multiple signals share the common medium, there is a possibility of collision. Multiplexing concept is used to avoid such collision, and transmission services are very expensive. What is the history of multiplexing? Multiplexing technique which is used in telecommunication, in which every telephone calls are carried through the single wire. Multiplexing originated in telegraphy in 1870, now widely used in communication media. George Owen Square developed the telephone carrier multiplexing in 1910. Concept of multiplexing. What concepts of multiplexing used? This is the n inputs and it gives a one output, and then one output gives you n output lines. N input transmitted through a multiplexer. Multiplexer combines the signals to form a composite signal. Then composite signal passed through a demultiplexer. First, n input line transmitted by multiplexer, and multiplexer combines the signals to form a composite signal. Means number of inputs lines transmit by multiplexer and convert into one composite signal. Then from one composite signal passed through a demultiplexer, this one composite signals convert into respective destinations and in number of n output lines. What are the advantages of multiplexing? More than one signal can be sent over a single medium. Bandwidth of medium can be utilized effectively. Now there are some types of multiplexing. First is the frequency division multiplexing, second wavelength division multiplexing, and time division multiplexing further divided into synchronized tedium and asynchronized tedium. Thank you. In this video I have discussed many topics which are related to your syllabus. You can these topics uh, these topics can be useful for all students who have need to computer network subjects knowledge. I have discussed all these topics from the syllabus of Btech students of Punjab Technical University syllabus, and this is the first module of syllabus I have discussed in this video. If you like my video, please like and share my channel with your